Good morning, guys and gals. I am back to do another section in the Swift Playgrounds Learn to Code series. We just completed logical operators on the last video, and I am excited to get started on while loops. I've always loved while loops. Just a little background on me. Um, I have been coding since really high school or a little bit before, but I remember in my computer science class back in high school, while loops were just a lot of fun to me. You could repeat things while a condition was true. They were super effective for what we were doing. We were writing in C++, which is an older kind of language. It's still used today. It's gone through updates and things like that, but it's been around a whole lot longer than Swift has. And Swift was actually born out of a language called Objective C, and all C languages kind of share a root. It's almost like speaking languages. So a lot of languages share a root with Latin. It's not that C++ was that original Latin root for programming, but just that, kind of if like with Romantic languages, if you know French, you know a little bit of Italian, or you could kind of muddle your way through. If you know French, you probably know you could understand someone speaking Spanish. So kind of a similar feel to that. So if you know one C language, you could look at some other C code and kind of know what's going on. I digress just a little bit, but that's kind of an exciting thing to point out here is, let's say you start learning Swift and you go through this and you have a lot of fun, but then you go find a job that has a job posting that has a requirement for a different language in C. That's okay. You actually could understand it a little bit, and with a little bit of just a little bit of additional training, you could program effectively in that as well. So that's the great thing about learning code. Once you know one language, a lot of the philosophy and a lot of the approach, even some of the commands, will transfer to another language if they're in the same family, or just programming languages in general, just because a lot of the tactics we use to program are all the same. So let's get started. So this is a great example. So when you're hammering a nail, you can't say, okay, I'm going to hit it 3 times, because if you hit it 3 times and the wood's a little bit different, or you don't hit it dead on one of those, it may not go in all the way, and you can't go, well, I said 3 and that's it, and so I'm going to keep going. You have to keep going on that nail instead of keep going on new nails. And so while the nail is sticking out, you're hammering away at that thing. So you could do a while loop to repeat a command or set of commands while a condition is true. This would be just like the for loop. We use our brackets to encapsulate what commands we want to repeat. And then we just say while, and then what's the condition? So while this is true, nail is sticking out, we'll hammer the nail. See, there we go. That's it. We're going to start with some while loops. It's a lot of fun. I'm going to restart this guy like we always do. And I had somebody, I've got a family member who's going through these things, and she mentioned the other day, like, hey, I'm in some of the later series. I'm in a loop, and I kind of get stuck in this endless loop. It's easy to get stuck in endless loops for while conditions, and so we're going to try to tackle that as well while we go through these things. So we have this column right here, and we have 1, 2, 3, 4, 5, 6 that have switches, and it says puzzle has a line of switches with a different number of switches each time the puzzle runs. So right now we have this many, but we may have a lot. It may give us one all the way down. And you'll notice we're not using a for loop to walk all the way down, because they want us to use the while loop. And also, this is actually kind of a good use case. Sometimes we may not know how far this little guy has to walk. And so if we do this while the condition is happening, then he'll keep going and keep going and keep going. But that can create a situation where they get stuck in an endless loop. Just like if statements, while loops allow you to determine when your code will run. A while loop runs the code as long as the Boolean is true. When the condition is false, the while loop stops running. Choose a Boolean condition for your while loop to determine when it will run. And so I could say, let's just run this a couple times and see what it looks like, because it will randomize this thing up, and let's see if we can see any patterns for what would be true. We have to do something. Let's do something. While I'm just going to say is on open switch. Move forward. So it works right now. If I just say, while I'm not on an open switch, I'm going to keep moving through here. And let's just run this and see what we get. I'm going to run it on the faster mark, just so we kind of see him move. And he did it. He moved through them all. And let's do it again. And you'll notice we can see a pattern here. So every time I run this guy, the very last thing that I care about is always an open switch. So that's a good conditional for this while loop. That helps us exit this thing cleanly. That helps kind of designate the terminator or the end of that loop. So we've moved forward, and then I can say if is on closed and toggle that guy. And that would toggle everything along the way. And you might say, wait, Wes, as soon as I toggle that, that condition is going to be true and stop it. So then maybe we need to reverse these, because it actually would. Let's just run it and see what that looks like. He stopped because he's now on an he is on an open switch, which makes that false. Sorry. Hard to talk through a reverse of an open switch. So actually what we need to do is we need to reverse these. The other thing reversing these will do is before I move forward, it will check and see if I'm on an open switch. You'll notice that very first block had an open switch on it a closed switch that we missed because we didn't check before we moved. So if we reverse those two things, we'll actually cover it. So let's go and check that. Toggle it, toggle it. Now I won't say toggle every time he does. And that's it. So all they were trying to do is get us to think through the process here on this, on what that while would look like. Let's keep going. All right. Start that page over. And this, honestly, is going to be really similar to what we did the last time. The only difference here is we're going through some portals, and we are on open and closed switches. And so it says, make your while loops even smarter using conditional code. So you'll need a while loop to toggle open every switch along 3 platforms. You can't simply use the condition is on closed switch, or the loop will stop running when you reach a portal or an open switch. So they add a little bit of complexity there. So add a while loop. So we can say while and let's just say is on closed, because they talked about that. Or actually, let's see here. This one might be a thinker. If I'm running through this and I move here, that's going to be open, so I want to keep moving forward. Let's just say, we know we're going to come back and change this condition here in a little bit. Let's walk through this thing. So we don't start out on something we need to address, so let's just move forward, because we know we're always going to be moving forward. If is on closed, we know we want to toggle that guy. And that would work, and this is probably the one that my relative said she got stuck on, because this would be a really easy one if we don't set that conditional right for that condition for the while loop. It would be easy just to make this guy run forever. So on this one, we don't actually end on an open switch at the end, so we need to figure out what else we might do here. Do they give us a hint? Let's see what they say in the hint. You need to carry out a set of actions. They don't give us another hint. Okay. So this actually would never run because we're not on a closed switch. What are our ideas here? While and the things we could do is blocked, is on close switch, is on gem, is on open switch, move forward, toggle switch, turn left, turn right. Not a lot of really important things here. Huh. While something, move forward. And they're going to randomize these. I could say, while not on close, and follow me on this for a second. What will happen is I'm not on a closed switch here. Oh. Nope, that would be a situation. Let's run this. I'll show you why that won't work. Well, I don't think that'll work. It may work, but I don't think so. I never end up on a closed switch because he keeps on a truckin'. Every time he does end up on a closed switch, he fixes it before we check on the loop again. But look, we're stuck in that infinite loop. Yep. So we need something else. We could say, we could even do a logical here and not is on open switch, but let me show you why that won't work too. That doesn't work either. Okay. Do we get another hint? There we go. While your character is not blocked. Oh, we forgot about the blocks. So that one is, we should have known that. That's rookie mistake. Sorry, guys. I was really kind of like confused by that. I was thinking, man, what do we do? When he gets to here, he's going to be blocked. So until then, he can keep walking happily. So, yep, that does it. Silly me. So we got a lot of open ones here. That's going to go really fast. There we go. You know, that's a great example of, you know, even people who've been programming for a long time can look at a puzzle and be stumped. One thing I'll tell you, if you ever are working on a coding problem and you're like, man, I am just stumped on this thing, walk away from it for a little bit. Go make yourself a snack. Go for a run if you're a runner. You would be surprised how your brain solves coding challenges when you're not sitting in front of a computer. It's kind of actually interesting that your brain continues processing those things, and your brain can figure it out in the background and go, hey, dude, I figured it out, you know? And then you can walk over there and solve it in 30 seconds versus just beating your head against a wall and continuing to try and try and try. Super effective. I can't tell you the number of problems I've solved that way. Okay. Let's reset this guy, and let's do another one. This will probably be the last one because this is not quite halfway through, but we're sitting at about 14 minutes right now, and I want to try to not keep these too terribly long. Choose the best loop to collect all the gems. Puzzle has 6 gems and a simple pattern for your character to follow. Best way to solve this puzzle is to use a loop, but which kind? You could use a while loop to keep moving while nothing blocks the way, or because you know how many gems there are, you could use a for loop. So in this case, I kind of like the while loop because we're in the while loop section, but also because sometimes you might write something knowing how many gems or things there are that you're supposed to do in a software, and then the definition of the problem changes 3 weeks later or 3 months later, and the number of gems or the number of whatever you're trying to do is different now. And so coding in a way that will satisfy a simple or a more complex set of rules as much as you can will help save you time in the future. So let's see if we can do the while loop here. I like that better. And notice, they've already written the turn and collect gem for us. So they've already identified the pattern of move forward, turn left, move forward, collect gem, turn right. And that kind of resets us in this little L, the tiny L, and then we do another tiny L, and then we do another tiny L. And as we're moving through, we just kind of keep iterating through these things. So if I were to say, while is blocked, I almost said while is not blocked, turn and collect gem. So that's really all I think they're asking us to do here. Let's run that and see what we get. Run faster. Yep, and it's going to handle the whole path for us. And then when we get to the end and we're blocked, it's going to stop. So that's a great little pattern. Super quick one. We may go ahead and do one more. This may run it just a little bit long, but let's go ahead and do it. So coding, it's important to study a problem, choose from one of several available solutions. Sometimes one approach can work just as well as another. They're saying you could have used either loop. Yeah, that's true. Oftentimes, an approach might end up being more efficient, reusable, or adaptable. And that's what we were talking about earlier when if you can kind of assume like what rules or conditions in a program you're trying to write are or rules in those that are hard and fast, meaning they're solid, they're never going to change, and which things are more flexible. If you can kind of code to protect against the flexible things, but code to enforce the really strict rules, then you're going to write more efficient code and more reusable code. So let's do one more. Why not? We're at 16 minutes. We can do one more. Choose the best loop and toggle the switches. There are several ways to solve the puzzle. You could use while loops, for loops, or a combination of the two. Figure out a pattern to toggle each open switch, and then see if you can break it down into a combination of two loops. It's up to you which loops to use. So if I go down here, I'm going to walk 4, take a right, 1, 2, 3, oh, and then I turn. Interesting. And then I go 1, 2, 3, oh, interesting. So wait, 1, 2, 3, I'm only moving 3 here. 1, 2, 3, 1, 2, 3, 1, 2, 3. So in all of these, I am looping through after basically this. Move forward, move forward, move forward, and then hook and a right. So I could simplify that, and I could just say, while I'm not blocked, move forward. And then I could say, we know we're going to need a conditional if is on close switch, toggle the switch. So go through here, toggle those switches. And then I know that I need to get a total of 1, 2, 3, 4. I'm going to have 4 patterns here. So I could start out with 4i in 1.4. I used to feel bad about using that I, but they're using it in their examples, so I'm going to do that too. So now we're using both things, and I'm just saying I know for sure there's 4 here, 4 patterns I essentially need to do, and while I'm not blocked, I'm going to move forward. And then I could say if is blocked, turn right. And that's going to help do this. So we're going to start the first one, and then I'm going to move forward through this. And then as soon as I can't move forward anymore, it's going to exit this while loop. So at the end right here, it's going to exit that while loop. Then I'm going to turn right. Then if I'm on a close switch, I'm going to toggle that switch. Then it's going to start the second loop. And I'm facing this way now, so it's going to go through here. And then, ooh, that doesn't work because look, I'm not blocked there. Interesting. We could say, while not blocked, or the rest of these are, this one might get a little challenging. Well, we can say, or not is on actually it's closed that we care about, because that marks a corner and that marks a corner that we need to do. But this one is already open. So we're using a little bit of logical operator to help give us some more complexity to this while. So we're going to move forward. If we're blocked, or is on closed, turn right. And we may get a final turn right here, and that would be okay. But let's try this out. So we're using our logical OR a couple of times. Oh, and they change it on us. Interesting. Okay. That's not going to work for us. We could go even further and say, interesting. So they changed up the switches on us. We could just use the switch. So if we're not on a closed switch, and we're not on a closed or an open switch. So anytime we're on a switch, it's going to exit out of this. So we'll move forward till we get here, and then it's going to exit out. So we're using our logical and here. So we're going to keep moving forward while we're not standing on a switch. If we're blocked, meaning we can't move forward, or we're on a closed switch, or is on open switch, and we can do multiple ORs like this, then we're going to turn right. So anytime we're on any kind of switch, I don't think there's an is on switch. Nope, there's not. That would be nice. We could write that later on, but I don't want to write something that we haven't been exposed to yet. If is on closed switch, toggle switch. I think that will do it now. Let's take a look. We toggled it. Oh, look, we got stuck. We were moving in circles here. Oh, you know what? So we need to move ourselves off of that switch. Interesting, folks. Yeah, this one is going to be a little bit of a challenge. So let's think through this again. This might work, and we could get through with something else. So we want to move forward. Okay, we could say while not is on open switch. And then we can say that one is probably going to do it, because but then we will I don't know that this approach is going to work for us, guys, because if we're not on a closed switch, if we get here, but what if this one's open and we're not blocked? That, I think, is going to fail too. I think this gets us through, but I think it just gets us through because we're lucky. So this actually brings forth a good thing to mention. Test multiple times. Watch this again. Let's test again. We fail because the actual situation is different. So this is important to know. Test your solution multiple times, because it could be that it works when the rules are a certain way, but doesn't work when it's not. And so let's think about what else to do here. So I could say is blocked, and that would be fine for this one, but it wouldn't for the other two, because we have one more space, and that's really what they're throwing at us here. let's just go to the hint so I don't waste... Oh, well, the hints aren't there. Let's see what else we could do for you. So I could come in here and move forward. This one. While I'm not on a closed switch. So anytime I'm on a switch, I'm going to turn. And I could cheat and I could say move forward to move me off of that. But then I'm going to end up with some extra movements at the end, I think. Let's look and see. That may be the cleanest solution, is just move us off of that switch. Oh, nope, that didn't do it. Let's look at our code real quick. Oh. And... oops. Is blocked. I don't think that's what I'm looking for either. That will turn us. Ah, see, we missed our switch and then we didn't do it. That's not going to do it for us. Okay, I'm going to try not to waste all your time here today. So let's start. I'm walking. If I'm on a switch of any kind, I need to turn. So honestly, this would still behave the same way because I'm turning because of the switch, not because of the, excuse me, not because of the blocking mechanism. So turn right, move forward. That would be, that's an acceptable thing to do right there. And then if is on closed switch, but I'm missing, these need to be reversed, and actually this will work. This is probably not the cleanest way to do this. There's more efficient ways, but let's look and see. Ah, see, nope, we missed it on the open. Oh, we can do or is on open. That gets us through. Nope, that does not get us through. Oh, hang on. That should be an and. That's the difference in ors and ands. They're always not on an open and andy closed, and that's why the or is inappropriate there. So that would always be true, because if I toggle a switch to the other direction, then the other thing becomes true, and as long as either of those is true, it'll keep going. What I want is, if I'm not on a closed switch and I'm not on an open switch, move forward. But if either of those things is true, I mean, if either of those things is false, then stop it. Oh, and I have this little extra walk forward there, which is not the best, but we're running a little late. That one's just, it's not going to be my best work, but I think that's a great place to end. We're already way over on time. You know, you're going to hit challenges like this when you run through. I'm going to play with this one a little more. I may post an update that just shows, you know, real quick short video that shows kind of how I discovered this. I think when I first went through this, I got the puzzle better or something, but I think I had a really concise solution for this. Maybe I'll wait a little bit more before I hit that start over button. But, you know, in the end, we got there. I'm going to test it one more time just to make sure it goes. While I tell you guys, keep at it. Don't get discouraged if you run into problems like this. If it gets really challenging, then walk away for a little bit and you know, just revamp your thinking on it and start out with a fresh approach. But keep at it. I believe in you guys. Have a great day.